So hey guys, today we'll be discussing the question called most profitable power in a tree. Now, in this given question, you have been told that there are two players, Alice and Bob. Let's start writing the names, Alice and Bob. And both the players, they have in the question that has been told that Alice start at node 0 and Bob will start at a particular node which will be provided to us in the input. Let's say that Bob started at the node X. Now, what we have been told is that Alice will always move toward the leaf node and Bob will always move toward the root node. And the root node is the zeroth node. And the value also they have told that the value of the root node is 0. Okay. So I just write it down for you. Okay. Now you have been told that this is the condition. Now you might think that okay, what is different about this given tree? Now in this given tree, the fact is that you can traverse. This is an undirected tree. Now the undirected tree means that let's say that you're traveling from 0 to 1 to this is fine, right? But the twist comes here. Let's say that Bob was starting at node 4. Let's say Bob was starting at node 4. Now the Bob can travel from node 4 to node 3. Now this becomes a undirected thing, right? So now the first thing intuition which we need to understand over here is that we do not have to think for this given problem as a tree. We do not have to think of the concepts called in order, post order, pre order. Okay, let's just simply forget that. So that is the first thing which I get from this question. Okay, now just reading ahead. Now next thing is that we have been each things have a node or some value assigned to it, right? So node 0 has a value -2 assigned to it, node 1 has a value of 4 assigned to it, and node 2 has a value. So all of these given values have been provided to us. Now the values can be positive and the values can be negative. Now in the case if the values are negative, what it means is that let's say that Alice, as I had mentioned earlier, that Alice she will be starting from the node 0 and she will be going towards the leaf node. What it means that to leave node 0, she will, if the value is negative, if the value over here is negative, she will have to pay the price -2. Okay, that's one thing. And let's say that Alice arrives at node 1. Now Alice has arrives at node 1. Then she can, if she wants to leave node 1, then she will get a reward. She will get a reward of 4. So that's one thing. Now, same thing applies for the Bob as well. So Bob will be at, let's say, node 4. Now, if Bob leaves node 4, he will get a reward of 6. Okay. Now, what about the case where Alice is visiting some node which Bob has already visited? Okay. Now, let's say that let's take violet color for Alice. Let's say Alice was here, and Bob was only here for let's say some reason. Bob was very slow walker. It's not the case. I'm just telling you. Now, this is just a hypothetical scenario. Now, at a given point, Bob has already visited node 3, right? So, if Bob has already visited node 3 and if Alice is going down this path, what it means is that this gate is already open. So, we have to think all this node as gates. Okay, the gates means that if someone has opened, if some person has claimed the reward, the other person cannot claim that award again. Got it? That's the twist in this question. So if for some reason, let's say that Bob arrived at here and Alice has already visited node 4, I'm just taking another hypothetical scenario. That means that if Alice has already visited here and she's somewhere here, let's say, at node 2, and Bob arrived at node 1. Now you might think that okay, Bob will get a cost of 4. No, he will not. Because Alice has already claimed the reward, and by claiming the reward, what action she is doing is that she's letting the she's opening the gate. That's the thing. So this becomes clear to us. Now the next set is that there is one more thing which I need to tell you about is that let's say that both arrive at particular node at the same given time. At like let's say at time t is equal to t, they both arrive. Again, a hypothetical scenario. I'm not going deep into it. Let's say that they arrive for some reason at t is equal to t. Now let's say the question says that if both arrive at a particular node at the same time. Alice arrives at node X, and Bob also arrived at node X. And the cost, like let's say the reward was something. Now the question says that both will get the 50-50% of the reward. Let's say the reward was 10, then Alice will get 5 and Bob will get 5. Right? So this is what the question is trying to say. I think so. Overall, it becomes very clear about this question. I think so. I've pretty much covered. I hope you are able to understand the question at least. Now let's just deep dive into the solution about this problem. Now I'm not going to show you how to write the code, but eventually what I'm going to tell you is that how to think for an approach. Now, obviously, this is a tree, but earlier I had told you that we are not going to use any post order, pre order, and in order things because this will simply not work over here. So, what we need to do is that first we need to create a adjacency list for this given because we have to make this tree into a graph. Why? Because only graph will allow us to have a because we have to establish a link. What link we have to establish? Let's say that if you are going from 0 to 1, we can also go from 1 to 0. So that's why we need an adjacency list. That becomes clear, right? And now, since we are talking about graph, what are the two traversal which is present in the graph? It's DFS or BFS, right? Uh, that's one thing which we have solved up till now in my head. Now, I'll give you one thing. In the question they have told you that Bob can travel from node X. He will always move towards the node 0, right? So, do you think the path to node 0 will be deterministic? I mean to say is that the path to node 0, let's say at some particular time at t is equal to t, Bob reaches that node 0. He would have always taken down this path. He would have always taken the path irrespective of whether Alice was going to visit this or not, right? I mean, there is no way that is going to change. So that is established. And the next thing I wanted to, one thing I think so missed out at 1 second, they will always, let's say that Alice was here at time t is equal to 0, and Bob was here at time is equal t is equal to 0. At 1 second, they will always move to their adjacent nodes. So apparently, Bob will move to node 3 and Alice will move to node 1. That becomes clear to us. So 0 to 1 and 4 to 3. So at when we say where are my location at t is equal to 1, and let's assume 1 is in 1 second SI unit, something like that. So t at t is equal to 1, I will say that Alice is at node 1 and Bob is at node 3. So this is also something which is very clear. So at any given we are doing something called we are working in time actually here. Now, I will tell you why this is important. Now, if you're working in the time, we need to keep track who has visited that particular node first, right? If for some reason, let's say that we take another set of nodes, let's take small a, b, c, something like this, and let's say we will introduce our characters also over here. Let's say that Alice arrived here, Bob arrived here. Now, at a given time t is equal to t, we know that in this given scenario, this is a very basic scenario. We know that the reward at this point will be split. But let's say Alice has traveled from A to B. Alice is here, and Bob has arrived here. How will we know whether Alice has claimed the reward of this node or not? Hence, hence we or you can simply say that uh, if I will tell you this way. If Bob is visiting some deterministic node, okay, he is going from node E to node A like this. He goes from year to year, year to year. Now, how will we know that when Alice is going from year to year, right? Now, for some reason, Alice wants to know that whether I can claim because the given question says that we have to maximize her profit, maximize. So Alice wants to always take rewards, right? But how will we know at t is equal to time t is equal to t whether Bob has visited the node C or not? This will be only possible if we keep track of the time. If let's say somehow we calculate like Bob was at time b t is equal to 0, Bob was at E and Bob was here. If somehow we keep track of this thing, then it becomes super duper awesome for us. So this becomes a very easy for us because when Alice will arrive over here, let's say at time 5 seconds, we would know that since 5 is greater than 1, we can simply say that Alice, look, you're late, so you cannot claim the price of this reward. So go figure out something else, go somewhere else. Right? This gate is already open. You can freely travel to it. Right? I hope this was clear. Now let's deep dive to what we were saying. First thing here is know that we have to think in the perspective of graph. Second thing over here is that also we need to keep track of visited nodes. And visited node, we can use some array. Why? Okay, tell me, why do we need a visited node? Because obviously, guys, if someone is going down this track, we need to see if if any particular node, actually any particular node is already visited, the other person cannot simply take the award. That as simple as that. Let's not complicate it. And third thing is that we need to keep track of time of Bob. Why Bob now? Tell me. Because Bob path is deterministic. Bob will always grow from one particular X node to the root node, and that path is fixed. So we will always know for sure that at t is equal to t, Bob was at this node. At 1 second, Bob was at this node. So if we can store somehow in map structure or any given structure, we can say that at node X, Bob had visited this at time at node X was visited by Bob with cost. Sorry, with time. With at time 5 seconds. Let's say. So we can use a kind of a map over here, right? So this is good enough. Now let's try to understand what this question more wants from us. So I think so we have explained the three concepts over here that we are going to use: graph, visited node, map. Now let's talk about the traversal thing, which I have earlier told you about. Now, what do you think? First of all, we have to use a DFS. I will tell you, I'm directly telling you the answer. We have to use a DFS. Okay. Now you might put a counter question that why can't we use a BFS approach for this thing? I will come to that, but let's discuss why we need a DFS approach for this thing. So before that, I hope you have a basic understanding of how a DFS works. Now, in a given DFS, you can simply see that I'll just let me zoom it a bit. Okay, it's not working, but anyways. So this is how our DFS works, right? We will have a vector node. This will be a graph, and this will be another vector of visited nodes, and this is the target node which we have to think of. Now, in this given question, we can all do one thing. We can run a DFS for Bob. What we can say that we can run a DFS for the Bob, and we will keep at every given node, we will keep track of the time at which Bob had visited that particular node. Cool. That becomes simple. Now, the next thing is that I'm just talking of basic DFS, how it would work. Now, a basic DFS, it will we will always start with some particular node, right? In a case of Bob, we'll start at node X. Then we will have a graph, and this is a kind of adjacency list. And then we will have a visited vector. We will mark the current node as visited. We will do some processing with the node if required, and then we will we'll check the adjacent node and check if they were visited using the visited actor vector or not. If they were not visited, then we will do a DFS search on that particular node. Now, this is a DFS approach. Now, what if we want to reach a particular target? Now, let's say that in our case, Bob wants to go from node 4 to node 0. What will Bob do? So in that case, what we just have to introduce a slightly change. What we need to do is that we will have a target over here. Now, in the given target, we will see if the current particular node which we have visiting right now doesn't matches to target or not. If yes, we will just return true. And same thing applies over here, right? Now, just the difference is that uh, if this returns true, because let's say that in the next iteration, it will call we visited this neighbor and this neighbor and target are equal. This will return true, and we will enter over here and say that we have found the target and just return true for the overall functions. And at the end, if nothing works, if we have visited all the adjacency vector nodes, we will just return false, right? Now, let's talk about now our current problem. Let's say that we are using an unordered map. I told you that let's say that we are using an unordered map to show that, okay, at node 4 was visited by Bob at time this, right? We are storing this information. And in our vector, I'm sorry, in an unordered map, and the next thing is that we are anyways utilizing this visited source. Now, this is same thing as here. Mark the node as visited. Now, this is same another. We check if the target has been reached or not. And the next thing we need to, as I told you that if we are keeping track of the time, at every recursive call which we do over here, we need to increment the time. So we increment the time by +1. This becomes also clear to us. And if we had found, if we have found the path to node 0, then we will return true. Now, one thing over here is special is that, let's say that we have visited some node, okay, and let's say that for some reason, Bob, it might be also possible that while doing a DFS search, since we are visiting all the adjacent node, right? Now, what might happen is that, understand this very carefully, guys. Actually, this is the most, it's kind of a bit tricky. So what might happen is that when we are doing a DFS search, what might happen is that is there will be one iteration, well, there will be one recursive call to go to this node 0, and there will be another recursive call to node 2. Now, ideally, what would have happened is that we would have ended up storing the value of this path, that let's say that we would have stored a path 2 was visited by Bob at time t is equal to, let's say, 3 seconds. So we would have updated unordered map. But remember that we are not doing that, because this is not the root, or this is not the root. So in that case, if we should return false, obviously, but we should also erase that particular value from our given unordered map. Because what complication might arise is that, let's say that Alice for some reason was going down this path of this thing. Okay, let's say Alice was going down this path. She will think that she will check unordered map if to see if Bob had visited this node or not. Now she will say that, oh, Bob has visited too, which is incorrect. So that's why you have to erase that. So this becomes something, this is something like you might write the whole code, but the small thing will actually, break your code, right? So we did a, now simple thing is that in this whole question right now, where we are right now, we have done a DFS approach and we have found that, okay, if Bob is taking down this path, we have tracked down that at node 4, he had this cost of something, he had this cost, he had this cost, and this cost. Now, what we will do for Alice? Now, I think so you might be able to understand that since for Alice, it becomes very simple because all she has to do is that let's say that Alice do a breadth first search, okay, because she will have to go to the leaf node, and the leaf node in our case is 2. Now, what will happen is that Alice will go start from node time t is equal to 0. Then she will go to node 1. And then she will check if someone has already visited this node or not. If obviously this node has been visited by Bob, then she will check what is the time at which Bob had visited this particular node. Now, if the time was actually less than Alice time, that means she cannot claim the award, right? So that's all, guys. That's all we have to do in this question. I think so. I'll just walk you through the entire. First of all, as we know, we will create an adjacency vector, right? Then we will create an unordered map to store the time Bob visited that particular node. Again, a visited node I had told you earlier. Then we'll do a DFS operation to find the Bob path to node 0. And then we will do a breadth first search to Alice. Now, breadth first search for Alice. Now, the reason is that we can use a queue. Now, what will this queue contain? This queue will contain a vector containing array with saying node, time, and income. So, at each particular iteration, we need to keep track the node which we are currently have, the time at which the current node we have visited arrived, you can say, and the income we have right now. So, we will do a DFS search. Now, what will happen eventually is that I'll just walk you through again. So let's say that Alice was here. She visited B, C, D, again E, F. So when we are doing there might be another possibility, right? So there might be different possibilities. We need to account for everything. So we will do a breadth first search on for Alice, and we will figure out that okay, at B, what will happen is that at B, we might simply say that okay, at time t is equal to 1 we arrived, have Bob arrived or not. It's as simple as that. And we will add all the adjacent nodes. We'll add F and C, and we will increment the time at t is equal to 2, we were here. And then we will store the max over here. If we have reached the leaf node, then we'll store the max. In case if we have not reached the leaf node, we might keep on adding the adjacent. Now let's say for this call, what might happen is that we will again add the adjacent. If C had adjacents E and D, we will add again the adjacent and we will just work out. As simple as that. So one thing over here is that I will come to the point that why we are using a DFS one. The thing is that we can use a DFS approach, but it might be a bit of complicated because at every iteration, think about it. At every iteration, we do not want to go deep dive into one particular node because DFS. What might happen is that when I do a DFS, let's say if there is a node from A to B, DFS will again go to node to C, node to D. So at this particular time, right? So every time you are just increasing the time, and it might become a bit complex thing to handle. A breadth first is a very simple thing because we know at t is equal to 1, we were at node B. At t is equal to 2, we will add, after that, we visited, at t is equal to 1, we visited node B. We will add all the nodes C and F and say that, okay, at t is equal to 2, I was at these particular nodes. So this becomes very simple to search, and all you have to do is that check for these particular nodes in an unordered map. So now what will happen is that if Bob, in this particular scenario, what might happen is that if Alice arrives at particular node, if Bob has never visited that node, we will take the full amount. That's good enough for us. But if Bob has visited the node, then it becomes a challenge. Then we will check, have Alice arrived before Bob? Then she will take the full profit. Otherwise, the profit will be split. And then this third scenario is that we will check the leaf node. If there is a leaf node, then what we'll do is that we will update our answer. Note we can store an int answer, something like that, and we can just keep incrementing if we have reached the leaf node. There might be many leaf nodes, so we will do a breadth. When we do a breadth first search, we might arrive at F, D, something like this, and we might just store the max of all of it. That's fine. Now, one important thing is that how do we identify a leaf node in a graph? So first thing is that for any particular, the size of this, what do you think the size should be for this thing? So, yep, the if the size of the graph, I'm sorry, I'll take you to the code actually. So what might happen is that the size will be 1 actually. Let me correct it here. The size will be 1 because it will have only itself. And I'm sorry, it will only have this particular node. And the only exception over here is that the root node will be not a in this question you can simply see that there is a root node A and its size of the root node is also 1. So that means that root node cannot be the leaf node. So obviously we have to take that in mind. And at the very end, what we can do is that we can explore all the adjacent neighbors. How do we, as I told you earlier. So yeah, I think so. Now you are able to understand this question more better. So again, we did a simple DFS search. Now, after a simple DFS search, we then did a BFS search for the Alex. Now, I have also told you why DFS search is better because it will tell you the path from one particular node to another particular node. And BFS search is more better for Alex because at every level, we know that the value which will be stored at Q will correspond to T is equal to 2, right? So this becomes easier for us to track. So that's all, guys. I hope you like the video. I will be not going to the code. More credits to this person actually, who has, yep, you know who actually. So you can refer to his explanation. So apparently, if you want the code, you can just simply look for the code and you will be able to understand it more better. The point of this video is that I wanted to make sure you understand the concept very well.